Hello, Juliet. How are you?
Yes, sir. So I'm fine, thank you. Yourself?
Fine, thank you. Timo is also here, but Timo is a quiet type, so he doesn't talk much. That's why I didn't come.
Yeah, he doesn't talk when you're there. He talks a lot.
Hey.
Timo, talk.
Let him be. Let him be, Juliet. Don't worry. They're quiet type.
So he's not quiet. He's quiet when you're around.
Like, seriously. Okay, so let's make this one. Want it to be more like tutorial because everything I'm talking about, I've already talked about already. I think we all know like most of the things I'm talking about in this particular PDF. You see that most of the things being talked about, we know them already, just that they are being turned around, you know, a little bit. So if someone is genuinely having a challenge, we can deal with it. You understand what I'm saying? So I'll be talking, but I want people to ask questions because if you don't ask questions, you wouldn't know. For example, before the last lecture ended, I asked you to compute the side lap, isn't it?
Yes,
And the formula was given to you, isn't it? And yet most of you were struggling to find it. But this is the formula here, as you can see on the screen. I don't know if you are looking at it. Yeah, if you look at the formula, it's very straightforward. What you need is the W, which wasn't provided at all. How do we even find what W is? W, you need the percentage to work out W, or you need W to work out a percentage. So you need one of them to compute the other. You can't compute one, based on the other. I mean, like, it's like a chicken and egg thing. So when I ask you that question, the first thing that you should be asking for is W and what it is. Because we knew J, we are calculated for J, but we didn't know W. You understand that? So you need to ask for it. So sometimes you need to know if a question is not giving you enough information for you to do the calculation. Okay. So we need to understand that the difference is in this picture. If you can't appreciate the picture on the board, you never W and B, you always get confused. Okay. This picture here is the secret to understanding, the air base. Okay, and I don't know what to call this one. This is the lateral advance, the W. Okay. So this is the air base. I don't know. There's no other name for the W. Are you okay? It's just a lateral advance. It's like a change in the strip from one strip to the other. The distance is W. Okay. So Juliet, I hope you appreciate it, Kaka. Look at the airplane. Look at the
I
airplane.
can't see the board.
Oh, really?
I can't see the board.
Well,
I'm trying to look
are
for
you
it.
using your phone?
Yes, sir.
Yeah, you can zoom. You can zoom. Use your fingers to zoom. It's if it's a good phone, you can zoom and see clearer. I don't know.
I can't find it at all. It's not that the board is there and I'm not seeing. I
You
can't
can't even
find.
see my
Let me
PowerPoint, the
leave.
PowerPoint I'm showing.
Yes. So let
But
me leave and come back again and see.
okay, leave and come back. Yeah. Mhm. It's time I think of you this way. Lighting is bad. I can see myself. Okay, it's better. This is what proves that I'm a black man. Can't have enough lighting. Take some of these bulbs, energy saving bulbs, they don't have enough luminance. You can't see things very well. Okay, so if you look at what we have on the board, I want you to appreciate it. If you get it, you need to tell me that, say, we really, really get it. If you don't, you need to let me also know that you don't.
So I can see now.
I see now.
Yes, please. Thank you.
Mm. That's okay. So, what do you think about the diagram on the board? Do you appreciate the two of them, the one on the left and the one on the right? So we could actually continue like this. Keep on going. So this is the fold overlap. Linear advance is in this direction. Linear advance in this direction. Okay, so we are flying this way. On the other hand, on the right hand side, here we are having the plane coming out of the board. Okay, so it's like it's difficult to show you exactly, you know, all the different, unless we actually decide to look at it from the top. Then we see that the plane had taken a lot of pictures coming out this way. But the focus is on the distance between fly lines. Okay, so if we went this way and took so many pictures, and we went this way, took so many pictures, then what it means is that we take one, take another, okay, take another. For your sake, I'll try to draw as many rectangles as I can. Take another. They are overlapping. That's why what I'm doing is that I'm just doing an overlap. Okay. So I'm getting 60% and I'm getting triple overlap regions. So typical triple overlap area is this one. So all these areas are appearing 3 times. They are appearing on 3 different photographs. Okay, that is what it means. Carrying on. Then we reach this end and then we turn around and we take another picture like this. Okay, so what does it mean? What does this line here mean? So there's one line here, another line here. So these are flight lines. There are two flight lines. And the distance between the two flight lines from here to here is the W. Okay. Please, I don't want you to be quiet. Otherwise, if I realize you are giving funny answers during exam, I'll give you 0. The reason I'm taking my time is this. I don't want you to. I ask you a question. I expect you to write W, write J, write W. I will give you 0. So now I want you to, let's be on the same page. Okay. It's because I care. That's why sometimes I can decide to ignore it. I assume you know it and I'll move on. But I want us to, like understand what is being taught. Are you okay? Please. So get it once. It's not complicated. If you are there thinking it's complicated, it's not one of the most complicated things. It's one of the most simplest things ever. So if you're not getting it, it's a serious problem. So try and understand it. This is W, and then we have B. B will be the center of the first picture here, and then the center of the second one should be somewhere here. So B is actually from here to here is B. Okay, so B, W, this is a difference, okay, B, W. So the distance between flight lines is W. The distance between the flight lines is W. I hope you are following. All right.
Yes, sir.
Any question at all? If you don't ask a question and I ask you a question, you give me the wrong answer. I'm telling you, I'll give you 0. Maybe negative. I'm not joking. Do you get it? Okay, let's move on. I think you get it. Just promise me that you get it. All right, so here's this formula. So how do we come by this formula? Are you okay? Percentage. This is percentages. So the percentage of the ground coverage without the lateral advance, okay, is called the percentage side lap, which means that is the amount of photographic coverage that is actually lost as a result of the overlap. Are you okay? It's W. Are you okay? All right. So merely W is equal to 0. Then we have 100% overlap. Okay, so these are things we need to know. All right. Like I said, the lecture, today's lecture is free, or this is a free for all. You can feel free and ask a question. I won't do any special. This is your tutorial, special tutorial. So if you have any question, ask it. I'll keep saying it on purpose. Alrighty, let's move on. I think we talked about this last week, loss of stereoscopic coverage. Yep. And then we did a calculation on this one, percentage NLAB calculation. All right, I think we did that. So you can't calculate percentage NLAB if you don't have the airbase. So here the airbase is 1400. And then we said, let's calculate this, and the class couldn't do it. Are you okay? The class could not do this. They couldn't even figure out what do we need and do we have it. I said calculate percentage side lap. And you know, I was surprised you didn't even ask me where is the W, which is the lateral advance, the spacing between the flight lines. Nobody even asked me what it is. Guys, it's not good enough. Please, please, it's not good enough. And I don't know if you even went and even looked at it, but I'm not going to talk about it. I'm not going to talk about it. I'm just warning you that if you carry on and you write anything to me as an answer which doesn't fall in, I'll be very, very, very cross and upset with you. All right. Okay, so a few things to know in our as part of our planning is that we need to look at the camera that is or the kind of photography that we use. They should have metric qualities. You see, metric qualities versus the pictorial qualities. Metric is meaning it's referring to our ability to measure from it, from the photograph. Are you okay? So I've given you an assignment. I hope those who didn't do it have made it ready or they've worked on it. Okay. Now, on that photograph, the metric qualities refer to, say, the side and side fiducials and the ability to print the photograph on a square format so that it comes out like you can measure it, because we are referring to what? The photo coordinate system. Okay. We are making references to what? The photo coordinate system, in which if someone gives you a photograph, then they expect that, or you should expect that when you actually draw a line from the corner fiducials, it should point to the center of what? The photo, which is the principal point, P. Is that okay? Why is that important? Because you need the principal point to be the intersection of the X and Y coordinate system, because we know the photographic coordinate system, we have the X and then we have the Y. Okay, so this is the Y and this is the X. Okay, so to be able to do this, you need to establish a center. Then you can use some set square or some long ruler and then draw through and then establish a coordinate system from which you can then, you know, find out the coordinates at any part of the photograph. Okay, and to find the coordinate, the definitions have been given in my lectures. You measure parallel to the X and then you get the X coordinate, parallel to the Y, you get the Y coordinate. So you end up with X, the example XA. So the small letter X, remember, always remember, in photogrammetry, once you make a mistake and you write letter X, 0 for you, means you are referring to the ground coordinates. We don't do that. Please pay attention and make your own notes about what I'm talking about. Is that okay? So XAYA will be the coordinates for if this point is point A. If this point is point A, then obviously the coordinates are XAYA, in which YA is from this point to this point, XA is from here to here. Okay, so that refers to the metric qualities. The pictorial qualities has got to do with the resolution of the image. Is that okay? So we can talk about a blurry image. Are you okay? Can talk about an image which is like not truly continuous and have issues with, you know, black areas that are not easily, you know, talking about contrast, things like that. Those are pictorial qualities. Okay. Also, we prefer to have a wide or super wide angle camera. Remember, we have wide, super wide, narrow angle camera. Are you okay? So the camera that is used during the World Cup and all that, those are, you can see they are very, they are narrow. Are you okay? When they are narrow, they have their own benefits. Okay, and when they are super wide, in area photogrammetry, we have the advantage. You tend to have a large base to height ratio. Once we talk about base to height ratio, the topic that should come into your head is what? Vertical exaggeration. If it doesn't come to your head, it means you've not been coming for some of the lectures. Is that okay? So we need a large BH ratio. Now, why do we need a large BH ratio? Because the large BH ratio will ensure you have greater parallactic angles. Are you okay? And so what is a parallactic angle? Pilot, what is a parallactic angle? Pilot, what is a parallactic angle? He's not listening to what I'm even saying. Festus, what is parallactic angle?
I'm listening, but I'm by roadside, so I'll get home right now.
Yeah, but give me the answer. I just want the answer. I don't want. I'm not saying stay or put your mic on. All you need to do is tell me what it is. If you are listening, it's a matter of just saying it. The parallactic angle is da 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 da. Okay, so you don't know. Please, guys, read. If you don't read, you'll be giving me funny answers. Even though you've done photogrammetry, most of you are done photogrammetry at survey school, you'll be surprised. You'll be failing this one if you don't read. Parallactic angles. All right. So, yep. So for topographic mapping and other quantitative operations, we look out for these, qualities. Okay. Now the errors become worse with increasing flying height, and they decrease with increasing x parallax, of course. We all know the difference between x parallax and then the y parallax. Also, that's another topic that we all should take note of. Okay, so this is the diagram explaining the parallactic angles subtended. So as we change the base to height ratio, of course, B over H, if H is smaller, if less, more divide, you get a larger, in this, the left hand side gives you a larger BH ratio, and the angles tend to be larger. So phi1 is greater than phi2. As we increase H, we get a smaller BH ratio. Okay, so the thing about photogrammetry is that it's not about photographs like that. It's really mathematical. All right. So yeah, we can talk about, for mosaics, relief displacement, tilt displacement, scale variation, degree pictorial quality. So I think yeah, we are aware that tilt, we don't want tilt. With the relief, these are problems. Relief and tilt in area photographs, we don't want it. But once we decrease our base to height ratio, we always end up. So what it means is that don't fly too high. Okay, don't fly too high. That is what it means. Okay. Photo scale for topographic mapping dictated by a required scale of map and accuracy. So your scale should always look at your objective. What do you really want to achieve in your mapping? You are doing photogrammetry because you want to map. So remember that photogrammetry comes under the larger topic of mapping. And one of the methods for mapping is photogrammetry. So even in GIS, we see photogrammetry being mentioned, land surveying being mentioned. All of them are supposed to be, adding to data collection, really. Of course. So if you have area photographs, okay, that you want to use to study your center line markings, and the actual width of the painted center line is 100 millimeters, high resolution 80 line per millimeter film can be used. What is the minimum photo scale? This is a typical example. Are you okay? So for every millimeter, you have 80 lines in there. Okay, so the resolution is every line you have 1 millimeter over 80. That will be the smallest object that can be seen. Are you okay? All right. So that's the calculation, 1 over 80. That will be the smallest object size. And then once you have the scale is, of course, distance, okay, on the map or the image over distance on the ground. So on the ground, the something that is 100 millimeter will be represented, you know, quickly if you use 1:8,000. Okay. All right. So we can also talk about enlargement. Remember that when you enlarge a map, then it's a simple multiplication of factor. Are you okay? All right. So we just either you divide or you kind of you multiply, but you need to know exactly what you are on about. In this case, we have an enlargement, and so we just divide. Okay. Yeah, and so on. So yeah, optimal scale, we need to look at it. Yeah, it shouldn't be too large, so because may end up being uneconomical. Juliet, why is it that if the scale is larger than necessary, it's uneconomical? Why do you think it's uneconomical to have this? This can be just one question I'll ask you an exam, 20 marks. Why is it that if your scale is too large, it may end up making the project uneconomical?
It means that you want me to explain it, right?
Why is it that
Why?
if you have a large scale, the photographs make the map, isn't it? In photogrammetry, the
Yes, sir.
photographs create the map. Are you with me? We are mapping with our photographs.
Yes, sir.
So when the scale is large or larger than necessary, it may be uneconomical. What does that statement mean?
So it means that maybe it won't satisfy the people. So you're going to waste money on it or something. It's going to be a waste of money.
No, when we
If it's
say,
not going to
okay, hold it.
satisfy.
Okay, what you said is you are sounding like a politician, not an engineer. Are you okay? So if the scale is
Okay,
large,
okay.
no, that's a truth. The truth hurts, but that's the truth. You see, if the scale is large in photogrammetry, it means are we flying higher or are we flying lower? That's the answer to the question. Are you with me? Because scale is equal to F over H. Okay. So for you to get a large scale, what should this value be? It has to be small, isn't it? Right? If more, let's divide. So the flying height determines the scale. All right. So if it's larger, means you are going to have to take more pictures. Do you agree? You have to take more pictures. If you have a larger scale, more pictures. That is where the economies come in. So now more pictures means, of course, it's going to.
So is it your network or it's mine?
I don't know. Maybe I think it's mine. Let me check. Yeah, I think it's mine. My credits. No. I have enough credits. I have.
I'm also having a problem. The line is breaking. The line is breaking.
431. You are not. You are not talking. You are not talking. When I ask you a question, you're
Yeah,
quiet.
I'm not home. Yeah,
Mm.
I'm not home. I'm not.
Oh, please don't. Marriage, so crying. I ask you a question. Don't mind me. When the day is this, blah, 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 like the moment you don't talk to me, when we are talking, I want you to talk when we are talking about the actual core stuff. Okay, this is not a problem. I don't need it can be fixed. I think it's got something to do with the MTN. Maybe the MTN people had an issue. I'm not using Vodafone now. I'm using MTN. because MTN too were having, Vodafone too were having some issues. Anyway, so here I want to hear all of you the same way I heard your voices just 1 second ago. Why is it that if your scale is too small, it reduces the usefulness or make it unsatisfactory? So this one, we understand it. What about this statement? If your scale is too small, it reduces usefulness or may make it unsatisfactory. What does it mean? Juliet, if they don't mind me, you mind me. Let's go. Do you understand the first or the if the scale is larger than necessary, it's uneconomical? Do you get that bit?
Say, can you explain it? Because the line was breaking when you were explaining. So
Okay.
yes, please.
If the scale is large, you look at the formula. I'm going to write the formula. S is equal to F over H. That's a basic scale formula, which can be modified a little bit when you have average scale introduced. Okay, so scale equals F over H. So to have a larger scale, I have to fly lower. Is that not so? So large,
yes,
if more, less divide, less height.
Let's divide.
More height. Okay. So I fly low, then I get larger scale. Now that's uneconomical because let's assume you have a piece of land like this with a whole lot happening on it. You're supposed to survey it. Okay, some structures on it and all that. If you fly low, you end up taking more exposures. If you fly high, you end up taking a few exposures. Do you get it? Two scenarios.
Yeah.
Okay, so uneconomical means you are taking more photos than necessary. Okay. Right, and then you have to do what we call area triangulation and extend the control, and the calculations become complex. You have issues, you have problems. Okay, so but then what about if too small? It reduces the usefulness. What about that? Because if the scale is too small, what happens when the scale is too small? You look at it in terms of a map. If someone gives you a map which is too small, tell me what are some of the problems you have with it?
You find it difficult reading the map.
You find it difficult. You can't identify things on it. You can't distinguish between your village has become like a dot on it. Is that not the case? So it becomes less useful. It reduces the usefulness. Is that okay? Or make it unsatisfactory. So this is what the statements here mean. Are you okay? I intentionally picked on these statements so that we look at it. So yeah, let's move on. There's something called C factor. We need to know C factor has got to do the contour interval. Are you okay? It's an empirical measure of contouring accuracy of a stereo plotter. It's the flying height divided by the contour interval. Okay, flying height divided by the contour interval. That is the C factor. So it helps us to know exactly, how accurate our stereo plotter is able to distinguish between the different heights. Are you okay? All right. So for different instruments, you can have different C factors. Are you okay? All right. So more or less like a standard. And contour interval for a map of 1 in 500.5, map in 1. So as it gets larger, the contour interval also increases with it. It makes sense, doesn't it? Okay. Because when you take a small scale map of, say, Accra, you realize that the height differences are very small. You can't even see the difference in height because Accra is relatively flat. Are you okay? Already. So on top of it. All right, so let's jump over some of these stuffs and move on. Look, you need to take note of what I'm really jumping over. It's very important. You can actually make an estimate of computer photo scale so that you have an idea your photo scale, because your photo scale will determine how you should fly, where you should fly, at what height you should fly. Okay, remember that. And so you can put a lot of factors, into consideration and use them to compute a scale at which you should be using for your projects. Is that okay? So there are all these factors here: contour interval. Okay, so I've actually explained all of them here. Focal length is FL, instrument condition, okay. So someone came up with this formula that can help you to estimate your photo scale or the scale. All right. So finding the scale is very important, isn't it so? But with the scale comes, so what height should I be flying? So the flying height. Now remember that we have this formula which is more realistic compared to the other one, which is too basic. Are you okay? S equal to F over H. This formula is too basic because most areas are not flat, are not really flat. They're not relatively flat. So this formula will work for most areas. All right. So you can reverse this formula, make H the subject of the relation, and then you'll be computing the flying height like this. Okay. Right. But anyway, anyhow you find your flying height is very important. But I'm seeing first determine the scale of your photograph and then working out the flying height. Because the scale will not determine. Yes, Juliet.
Please go back to the formula. What's the small h?
The small h is the height of any point on the ground above D2. The bigger h is a flying height. I think when I was going through this, Juliet, you were not there. Hey, Juliet. Are you guys
the small h?
The small h is the.
I didn't hear the small h, but I know the
No,
big.
but this is not the first time we are using this formula. Under vertical photographs, I have already talked about this formula. We've done calculations.
Yes, I was sick. That's when I wasn't there.
Okay, that's fine.
That's fine.
I can't fight with a lady and win. I know, so I've given up. So the small h now, HAVG is actually the average height on the ground. So let's say so many heights on the ground, then you find the average of it. That is HAVG. Okay, so HAVG is equal to H1 plus H2 plus H3 plus HN, where N is the number of points. Are you okay? That you've observed the heights for. Okay, that is the HAVG. But if you want to find the scale at a particular point, say B, then S is equal to S over flying height minus H, then B. So the height at that point, there's a scale there. That's how you get a scale for that. Okay. So yeah, so this is this formula. I think we've touched on it before. Let's move on. Okay, so the Zoom meeting will end. This session will end. When it ends, let's rejoin with the same link and then continue from there. So we're going to talk about ground coverage of photo. If the case where photo is greater for high altitude, okay, so it's low altitude, ground coverage, okay. So you can see that where you actually fly very high, your ground coverage is larger, and then when you fly low, your ground coverage is smaller. Okay, you need a few photos if you fly higher altitude. Okay, very high altitude is more expensive. We need to know that, and you may need special equipment. You may need oxygen. Okay, there's a decrease in oxygen available for you. Okay, so when we come back, we're going to talk more about some things. We are preparing to fly. This is what you need to be an engineer working for some drone company. This is the knowledge. You see, apart